For decades, Pluto has drifted like a ghost at the edge of sunlight, a frozen world of endless twilight. Once hailed as the ninth planet, now reclassified and almost forgotten, it remains a silent sentinel beyond Neptune's orbit, distant, cold, and wrapped in mystery. Out there, sunlight fades to a whisper. Temperatures drop hundreds of degrees below zero, and silence stretches for billions of miles. Pluto circles the Sun alone, a relic from the dawn of creation, untouched and unseen for generations. Then, in 2015, humanity arrived. NASA's New Horizons spacecraft, after nearly a decade in flight, swept past Pluto, and what it revealed stunned the world. Instead of a dull, dead rock, it found a dynamic world of ice and shadow. Towering mountains of solid water ice, plains of frozen nitrogen, and a faint blue atmosphere that shimmered like silk under the sun's distant glow. But hidden inside that data was a puzzle that defied logic. Pluto's atmosphere was far colder than physics allowed, over 30 degrees below every prediction. Something was bleeding heat into the void, something unseen and unexplained. For years, NASA's scientists recalibrated sensors and rebuilt models, yet the mystery remained. It was as if the planet itself was stealing warmth from its skies. Then, in 2017, planetary scientist Shi Zhang from UC Santa Cruz proposed a radical idea. What if Pluto's delicate haze wasn't passive dust and gas, but a living chemical system regulating its own temperature? He theorized that tiny particles called tholins were absorbing ultraviolet light from the sun and re-emitting it as mid-infrared radiation, radiating heat away into space. Instead of trapping warmth, they were cooling the planet, forming a natural thermal shield above the surface. The concept challenged everything scientists believed about planetary atmospheres. But Zhang made one testable prediction. If his theory was right, Pluto's haze would emit a faint glow in the mid-infrared spectrum. A signal so weak that only one instrument could ever detect it: the James Webb Space Telescope's mid-infrared instrument, MIRI. In 2023, that test came. An international team led by Tanguy Bertrand turned Webb's golden mirrors toward Pluto and its moon Charon. For the first time, they could separate each world's faint heat signature. What Webb saw defied expectation. Pluto's infrared glow was stronger than it should be, far too strong to come from its icy surface alone. Something high above was radiating heat outward. When the scientists isolated Pluto's spectral lines, the pattern matched Zhang's prediction perfectly. The haze wasn't a byproduct, it was the source. Pluto's atmosphere was glowing in infrared, alive in a chemical sense, breathing heat into the cosmos. The discovery rewrote planetary science. For decades, gases were thought to control climate: carbon dioxide on Venus, methane on Titan. But Pluto proved that solid particles, microscopic tholins, could dominate instead. As sunlight strikes Pluto, it sparks chemical reactions that build these tholin layers. They absorb ultraviolet rays, emit infrared light, and cool the planet from above, forming a delicate self-balancing cycle. Even more astonishing, Webb found that methane escaping from Pluto drifts toward Charon, where sunlight transforms it into reddish organic compounds. Pluto is literally painting its moon with chemistry from its own sky. And as breathtaking as this was, it was only the beginning. Because when Webb looked deeper into that strange blue haze, it found hints of something even more extraordinary waiting to. The James Webb Space Telescope drifted in its endless orbit, its golden mirrors staring across the dark. Most days, it saw nothing unusual, just the slow shimmer of cosmic frost. But one winter night, the data stream changed. A whisper appeared inside the readings, faint, rhythmic, deliberate. A heartbeat hidden inside Pluto's light. At first, engineers thought it was interference, cosmic radiation, a sensor echo, or an alignment glitch. Yet when the same pulse returned a month later, matching frequency, amplitude, and phase, coincidence collapsed. Something was pulsing out there, far beyond the sun's warmth. Every 6.4 Earth days, Pluto's own rotation period, the pattern repeated. Not random. Not noise. Something alive with mathematical precision. NASA's analysts pulled the old New Horizons archives from 2015. Buried within terabytes of raw telemetry, they found a clue. Beneath Sputnik Planitia, the bright, heart-shaped basin on Pluto's face, radar echoes once showed a circular region that reflected signals too strongly to be normal ice. A zone of warmth, barely a few degrees higher, yet consistent, spanning hundreds of kilometers in perfect symmetry. It had been dismissed as instrument noise. Now, it looked like the source. Webb's next sweep confirmed it. The pulses came from the same coordinates, deep beneath that frozen plain. And their frequency was not static. It fluctuated gently, in harmony with Pluto's tidal lock to its moon, Charon, as if the two worlds were sharing an invisible electrical thread. Researchers began stacking the data, aligning every pulse. Hidden within the waveform they saw layers, harmonics nested inside harmonics, ratios echoing the Fibonacci sequence, the golden spiral, and resonant patterns seen in biological systems. Not random. Not chaotic. Structured. Intentional. At the Goddard Space Flight Center, teams ran spectral and Fourier analyses for weeks. Every model failed. No known natural process could generate that precision from frozen rock and methane. It was as though Pluto itself was acting like a planet-sized circuit, pushing currents through its ice. To some, the idea was madness. To others, it was the beginning of a new physics. When the signal amplitude shifted slightly each time Webb observed it, almost like a response, the team fell silent. One researcher simply whispered, "It knows we're watching." Official reports avoided the implication. They spoke instead of periodic thermal resonance, anomalous subsurface reflection, and possible cryovolcanic activity. But the language could not hide the truth spreading through hushed hallways. Pluto was not dead. It was doing something. Some scientists suggested that the pressure and radiation within Pluto's ice might create conductive crystals, natural superconductors formed from frozen methane and ammonia compounds. These structures could carry charge and release it periodically, creating a planet-wide electrical heartbeat. Others imagined a buried ocean still alive beneath the ice, its salty currents generating magnetic oscillations as it slowly freezes and melts with each orbit. Whatever the mechanism, the energy output was far beyond anything expected. And it was growing. By late 2024, Webb recorded a 5% increase in pulse intensity. No known thermal process could explain that change in so short a time. It was as if the planet was charging itself, or waking up. When the frequency aligned perfectly with both Pluto's rotation and Charon's orbital resonance, mathematicians found another pattern. The timing matched ratios used to describe orbital stability in gravitational systems. The same ratios found in planetary rings and living cells alike. The realization shook even the skeptics. Pluto was interacting with its environment on a cosmic scale, absorbing energy, transforming it, and releasing it back as precise mathematical light. For decades, Pluto was the symbol of silence, a frozen tomb at the edge of sunlight. Now it was something else. Something listening. Something speaking. In the dark beyond Neptune, a heartbeat echoes through the ice. It whispers in numbers, in ratios, in patterns that feel too perfect to be chance. A message written not in words but in mathematics, the language of creation itself. The question is no longer if Pluto is alive, but what it's becoming.